We'll start. We are very glad that Céline could recover from the microbes and join us finally. And she will talk about scenarios, a subject Jean-Pascal raised, as she works at CIRED in collaboration with NCARC, but you can tell us a little more about that on RCPs and SSPs, the scenarios for the climate research.
Okay, thank you. Well, I'm very happy to be here and very sorry to have missed the beginning of the week, because by judging from the presentation and discussions that we had for just yesterday evening and today, I see that I have missed a lot. So what I will try to do is to present some ongoing work done by the research community from the work group 3, the economists of the IPCC, on the socio-economic scenarios, and I will present also what I did with some colleagues in that community work. So I have to apologize, it's really work in progress. So I hope, and I'm sure that your reactions and your questions will be very useful for me. And what I hope is that what I will say will be also useful for you. So I will try first to say a few things about this framework for the development of new socioeconomic scenarios for climate change research. What is that framework and what are we doing? Then I will present what we did in CIRED and with some colleagues from NCAR in that framework, and to help select a few socioeconomic scenarios for climate change research. And then I will also try to show you what we're starting to do when it's not about choosing a few scenarios, because in fact, it's not about choosing scenarios. So the traditional way to do scenarios in the climate change community, at least, is a very easy and sequential way. You start by doing some scenarios, some socioeconomic scenarios. Then you use models that translate that into emissions. Then you take some carbon cycle models and chemistry models to translate emissions to concentrations. And then you take climate models to translate that to temperature and all relevant climate indicators.
Is that the time axis, the abscissa?
No. Yes.
Yes, yes.
Time axis.
And also the arrows are the process. So there's also some idea of time. You start by working on socioeconomic scenarios and you end with climate results. That's the traditional way to do things, and that's how it has been done until now. But and you probably know the SRS scenarios that have been built and used in that way. But it was time, the SRS scenarios were done at the end of the 90s, and for many reasons it was time to update the scenarios and do a new generation of scenarios for climate change research. And it was decided to change the process, mainly for two reasons. First, to try to speed up a little bit the process, because in fact it takes time, especially for climate models that take some time to run. So arriving at the end of the chain is an issue for doing the science. And also the process was changed to try to have more interdisciplinary communication. And what was invented was the parallel process. The idea is to start in the middle with concentration scenarios. So first, everyone agrees on some concentration scenarios. From there, the climate models can start working and do Earth simulation model to have results on climate. That's done. That was published in the first part of the IPCC report last autumn. Very good. Now for us from working group 3, it's a bit more complicated because we have to reverse engineer the socioeconomic variables that are compatible with the concentration scenarios. So just to show you, these are the 4 concentration scenarios that were decided in the community to coordinate the research around those scenarios. So those are the representative concentration pathways, and I think you already...
Do you need those in CO2?
It's a forcing. What's forcing?
Yes, this is enforced. Yes, this is a forcing. This is a forcing. And that was chosen to actually span the range of what is existing in the literature and try to have one very high, one lower, and take only 4 to avoid the middle, to focus all attention on the middle one. So, and the whole idea of this new process, not starting with socioeconomic scenarios, is that in fact there's not one socioeconomic scenarios that correspond to a concentration pathway. It can result from diverse combinations of socioeconomic pathways. So the whole idea is that there's not a bijection between the scenarios, and that our task was to try to explore those combination of socioeconomic variables that can lead to these concentration pathways.
Why have them been called representative concentration, and they describe representative forcing?
Okay.
Why not call them representative forcing?
It's just an easy way to represent them, but they are in fact expressed.
Concentration.
Yes. Yes. So now the difficult task is to reverse engineer the scenarios that are compatible with that. And for that task, fortunately, my colleagues invented the matrix.
That's you.
It's quite as difficult to understand as that one, but I will try. So this is the matrix. So again, the idea is that there's a single correspondence between a socioeconomic scenario and a forcing level, a forcing path, a concentration pathway, but that there can be a matrix. For some reason, the economists thought that it was not a problem to have one in the middle. So we have 5. They decided that 5 was a good number. Okay. And then the whole idea is that we will have some reference socioeconomic pathways that are evolutions of the different socioeconomic variables in the absence of climate policy. And that will lead to some emission scenario and to some concentration pathway somewhere in the matrix. And then we add climate policies to try and reach the given concentration pathways that were defined by the representative concentration pathway. So the whole idea is to have multiple socioeconomic pathways and then look at what happens if we don't care about climate, and then look at separate climate policies from all the rest of the socioeconomic evolution. And then these are the policies. Maybe for some, in some socioeconomic worlds, some targets are not attainable. And that's the whole idea. Here you can look at the cost of reaching a given climate change target. And if you compare here, you can look at the influence of the socioeconomic variables or of the world you are in. Okay? So
is it a photograph at time t?
No, these are pathways. So it's a trajectory, and it's for the whole century.
But you have a forcing level?
It's a trajectory. Yes, it's a trajectory.
So it's a trajectory. Okay.
Okay.
That's the
But
forcing
maybe
level.
the key is the number, the forcing level is the value in 2100. Thank you. But it's a pathway, is there, but it's characterized by its value in 2100.
Oh.
Okay. Yes. And the whole idea is to coordinate research to then have comparable results and to try to organize the results in the matrix to have on one side the mitigation costs to reach the given forcing level, and on the other side to have the adaptation cost and the residual impact cost, and to organize the information from various studies on different sectors, different regions, etc., in the matrix. So that's the whole idea. And in the end, to have a comprehensive assessment of climate change, impact, adaptation, and mitigation. So that's the goal. Now, it's, as I said, it's something that is in progress. And the idea was, okay, we want a few socioeconomic scenarios. Why a few? To coordinate research. It's really so that everyone uses the same. And that's the only goal. And then the idea was it should be relevant for both mitigation studies and for impact and adaptation studies. So our scenarios should try as much as possible to cover the uncertainty space along two dimensions that are not very clearly measured now or defined, but that we can call the socioeconomic challenges for adaptation and the socioeconomic challenges for mitigation. And the idea is that we want 3 scenarios that are along the diagonal, so where challenges co-vary. So we want one scenario with low challenges, both adaptation and mitigation, one in the middle, and one with high challenges. And we want also off-diagonal scenarios, one that has high challenges for mitigation, but not so high challenges for adaptation, and vice versa, one that has high challenges for adaptation, but low challenges for mitigation. And what the community tried to do is, okay, how do we select, how do we build those scenarios? Of course, the problem is that there are many uncertain things, and really uncertain in the sense that we don't even know the possible states, future states, and we have no idea of the probability well, we have some ideas for some of the elements that I have here, but we don't know future technologies exactly, the cost and potentials. We don't know future lifestyles and behaviors. We don't know future institutions. We don't know future policies. We don't know future location of people and activities, etc., etc. So the idea is from all these parameters, how do we select a few scenarios that are consistent and contrasted along the lines that we want them to be contrasted?
Don't you think that some issues should have more than one interrogation mark and some less? Because, for example, demography, is that uncertain? We know more or less, or future location of people. Don't you think so?
Yeah, well...
Others, we really...
Yes. Of course, if you talk to demographers and if you look at demography projections, there are still some variation. So yes, yes. So of course, for some things we know a bit more. For others, we know less, for sure. But that was the idea, and Now I will try to explain what we did. Like the traditional way to do that is just to bring a lot of people in one room and try to discuss and try to come up with some storylines that seem internally consistent and seem contrasted. And that's how, more or less, SRES were done, for example. Here, that was done also, bringing experts of different fields in a room and trying to come up with some storylines. What we thought is that it would be also interesting to complement that approach with an approach that will more systematically explore the uncertainties. So that's what we did with some colleagues at NCAR. And we're using a model. I was not planning to tell much about the model. We can discuss it if you want, but we're using a model that is a global model with 12 regions, 12 sectors. It has endogenous GDP, energy markets, technical change, and an explicit representation of technologies. You will tell me, but what's exogenous? Demography is exogenous. Labor productivity growth is. Technologies, they are represented by a maximum potential and also some cost and some possibility of learning on the cost. We have exogenous fossil fuel reserves, and we have some exogenous parameters of some functions that represent energy efficiency, responding to energy prices, and also some functions that represent the evolution of lifestyles and behaviors. Those functions have some parameters. And what that tries to represent is how motorization rate will evolve with income increasing, or how many new flat screens you will want as you become richer, etc., etc. And what we thought is, of course, on these parameters, we don't know the values. We have some rough ideas. We never have some neat probability distribution on the values. But we can have some ideas, and we thought, okay, let's just run all the combinations of the parameters that we have and have a database of scenario, and then use that to try to explore a little bit systematically the uncertainties. So yeah, that's what we did. And we have some hundreds of scenarios. And there's some ideas, like the sort of, you have then some trajectories of GDP evolution, of emissions, etc. And we thought, okay, let's see if we can map our scenarios to that space. That means that we need some measure for the axes. Not easy. Of course, how do you measure socioeconomic challenges for adaptation? There you have, of course, governance and institutions are important, we know. Probably wealth is also important, but there are many things that are important here. Let's just take something that is very simple. Let's take GDP in low-income country. It's a rough approximation, I know. Then challenges for mitigation, again, probably institutions matter a lot. Let's take something. Let's take global CO2 emissions. It gives the volume of the problem. And now we can map our scenarios. Each is, in fact, one of my 400 and something scenario along the space defined by the two measures that I chose. We can do it for other indicators, and we did it for other indicators, but just to show you. And then we can say, okay, these are my SSP1, the low challenge scenarios, these are my SSP2, etc., etc. And I can now use data mining techniques to see what combination of parameter is bringing me in one space, in one domain of the space. And then that can maybe inform a little more on which, if I had to choose 5 scenarios, which were they? And what we have as a result is that the main determining factor for being here is to have energy sober behaviors. Then also rather fast convergence of labor productivity of low-income countries to the leader, and either medium or high energy efficiency. What doesn't matter is fossil fuel availability, because you don't use much fossil fuel in those scenarios.
What's leader growth?
So,
What's leader growth?
that's the growth of the country that has the highest labor productivity per sector. And for the SSP5, what is the determining factor is to have high availability of fossil fuels and fast leader growth. What doesn't matter much is behaviors or energy efficiency, etc. So that was used to better inform the storylines to actually select and build the 5 scenarios that now will be used to coordinate research efforts. So that was our contribution. But then, in fact, it's a very specific goal to select a few scenarios to coordinate research. It's useful, but it's not the most interesting thing that you can do with scenarios, I think. And now I will try to show you what we're starting to do with that database of scenarios that we now have, and what sort of information you can get. The first thing is that we can try to, we can say, okay, let's evaluate the mitigation costs for all our scenarios. So not have 5 columns, but have hundreds of columns, and try to see then what determines the cost and what we can say. So that's what we did. So we took a cost efficiency approach. So it means that for all our scenarios, we defined a climate policy target in the form of an exogenous CO2 emission trajectory. So we don't include the uncertainties, the chain of uncertainties to climate change, and we don't take into account the cost, the cost of climate change damages. We really have this approach to fix a target and see how we can reach it. And we let the model reach it with sorry, a global carbon tax with 2 ways that the revenues can be used. One way is to give it back to households in the form of a social transfer, a little bit like the chèque vert that was discussed in France at the time that we were hoping that we would have a carbon tax in France. Or it can be used to reduce pre-existing taxes, like labor and capital taxes. And then there's a second difficulty, is the metric to measure the cost. Of course, in theory, you could always use the welfare cost, but that's not what is done in practice. In practice, the community is using a variety of cost metrics that are, in fact, measuring different things. So we chose to concentrate on 2 of on the most common, the carbon tax, that measures the marginal cost to reduce emission, and the macroeconomic cost, that is the GDP variation between a scenario with a policy and the scenario without the policy. So these are the 2 cost metrics that I will show now. And again, these are my 400 etc. scenarios along the 2 cost metrics that I was just presenting. And the first thing that I want you to see is the range of results. The macroeconomic cost in the scenario, they vary from almost 0 GDP variation between my scenario with a policy and my scenario without the policy to 16%.
Reduction of GDP?
Yes, discounted GDP over the whole period with a 3% discount rate. We can use another discount rate. But that's the value that the community is using. That's the only reason why I'm using that one. And it doesn't change much. And then the carbon tax from less than 40 to more than 300. So that just show you that with the state of the art of current models, the parametric uncertainty is such that we cannot expect to have a precise number, and that we're modeling for insights, not numbers. Now, what sort of insights can we have? First, you see here are the group of scenario where the revenues of the carbon tax were given to households in the form of a social transfer. And these are those where they're used to reduce pre-existing taxes on labor and capital. And that matters a lot. You see, it changes both the macroeconomic cost and the carbon tax. It reduces a lot the cost, but increases the tax. First thing. Second thing, well, here my two metrics are more or less correlated. And the parameters that determine them most are the technology, the assumptions that I take on the cost and potential of my low carbon technologies. But in that other case, there's no correlation anymore. And the determining factors are not the same. So that's already an interesting result. Then also, looking at the macroeconomic cost, the variation between the scenario with a policy and the scenario without a policy is a bit problematic if you are in a cost efficiency approach. Because, well, at least for the uncertainties that we looked at, the GDP in my no policy scenarios vary quite a bit between the scenarios. So, and the emissions also. So probably the benefits from avoided climate change would vary. But as I want to exclude that from my analysis, I in fact do not want to concentrate on the macroeconomic cost. A better measure of the cost efficiency of my policy would be to look at directly to the absolute GDP level reached in my policy scenario. So if I look at that third indicator, what I see is that there's no strong correlation. And the determining factors are not the same. So if I concentrate on that metric, I will implicitly give the policy message that we should concentrate on carbon technologies. If I look at that other, what I see is that behaviors and energy efficiency are in fact more important. Why they're not so important for the macroeconomic cost of policy? Because behaviors and energy efficiency also matters for the GDP in my no policy scenarios, because there's a link between energy and GDP. Even if I don't have a carbon price, there's already a link. So, okay. Is that more or less clear? Not really.
I haven't got it.
Well, in fact, if you look at the difference between a scenario without a climate policy and a scenario with a climate policy, your assumption on low carbon technology will matter a lot because they're not used in the no policy scenario, not very much. So they will make a lot of the difference. But if you concentrate on the absolute GDP that you reach in the policy scenario, then something else will be more important, and it's energy efficiency and behaviors. Why I don't see them so much when I look at the variation with the baseline is because behaviors and energy efficiency also matter a lot for the GDP level that I reach in my no policy scenario. So it doesn't make a lot of a difference. Is that more clear? No.
It's complicated anyway.
Anyway, it's just an illustration to show that depending on the cost metric that you take, you will have some different implicit policy implications.
There are some correlations inside the stuff, so this is how,
Exactly.
depending on what you focus on, you have these different lines.
Exactly.
Can you repeat the meaning of y-axis?
This is the absolute GDP level that I reach.
It's per capita, is that right?
This is a per capita. And this is normalized to 1 for my ensemble mean. Because I don't really, I mean, what I want to see is if I grow more or less than the mean. I don't really care. Well, I do, but for the comparison, it's not important. So this is the absolute GDP level that I reach in my policy scenario. This is the difference between that level and the level that I had in my scenario with all the same socioeconomic variables, but no climate policy. So this is the difference. This is the difference between two levels, and this is the absolute level. And these two are not correlated and not determined by the same socioeconomic variables.
Are there between energy efficiency plus and energy efficiency minus, are there figures behind, or is this trends?
They're explicit assumptions. And this means low energy efficiency, and then this means high energy efficiency. So, and this is intuitive. I mean, there's no counterintuitive results. Energy sober behavior, increased GDP, high energy efficiency, increased GDP. That's, but more so than do optimistic assumptions on low carbon technologies.
How do you get these points by numerical evaluation of the scenarios, or is that the result?
Yes.
You had computer runs?
Exactly. We did hundreds of computer runs, changing the parameter values, and each is a result of one single run. Okay. And now another thing that we're trying to do is to try to use the database to give insight to it. In fact, the question is really not about choosing a scenario. I think it's about choosing actions in the short term under deep uncertainty about the future. I don't have to choose my whole trajectory. I have to say, okay, what do I do now, or in the few years coming, and that is what matters. And so really, it's not choosing, oh, I want to follow that scenario or this one. Is okay, given the uncertainty that is for some part irreducible, and on some of the parameters I have really no grasp. Well, for some policy can have some impact. And behind some parameter, you can always see some policy. Even for demography, you can always see, okay, it's uncertain, but you can always see some policy behind some parameters. But the sort of questions to try to choose the actions in the short term that we want to answer is to use the database to say, oh, do we have, can we figure out if there are some necessary and sufficient conditions in the short term to be in good position to reach a long-term desirable goal? Can we know if we are on a desirable trajectory? Or can we change? How can we change from an undesirable scenario to a more desirable one? Or how can I build a strategy or a policy that is robust to uncertainty? And that's the sort of thing that we're trying to do. So to use, to look at dynamically the scenarios, to say, okay, if we want to be in that domain in the long term, this is my goal. And we can define that. And there can be some debates about which is the goal. But let's say we manage to define one. Try to look at in the short term. Do we have some conditions that we have to respect in the short run to be in a good position to actually reach our long-term goal? Or we can try to use the database of scenario to test strategies along the robust decision making. I don't know if you're familiar with robust decision making or not. The whole idea is to choose a strategy. Let's have a global carbon tax of $100 per ton of CO2, increasing that way, starting in 2020, and etc. We can test the strategy in the scenario database, try to characterize the vulnerability of our strategy, try to identify the cases where the strategy doesn't reach its goal, and see what we can learn from that to modify the strategy and to test a second strategy to see if it's more robust to the uncertainty. So that's the way that you can use scenario databases or large number of computer runs to try to have a more robust decision making under deep uncertainty. So that's this is a way of using scenarios that is very relevant for a local scale decision making for very specific questions like what sort of strategy does water utility can a water utility implement to give water for the area for the next 50 years under uncertainty about future climate, future population of the area, etc., etc. And it's used like that. Of course, at very aggregated and global level, as the level I'm working, it will just give very broad ideas. But the sort of things that we can do is, well, this is the dynamic view of the scenarios. We can also look in the short term where they are and look at, for example, scenarios that start in SSP5 domain. And these the scenarios that start in SSP5 domain, they very much follow the logic, okay, let's grow first, concentrate on growing first to have the capacity to adapt to climate change. And let's not worry too much about climate change mitigation now, because we'll have the capacity to adapt tomorrow. And what we see is that, okay, this strategy has some issues because, of course, it makes the climate problem worse. So even if you have capacity to adapt, you have to adapt to something that is worse. But even without taking that into consideration, what we see with our database of scenario is that this is a very fragile strategy. Because the scenarios that start in that area, none manage to go to, well, two only, but manage to go to the good domain in the end. The end points are the red dots, and the short-term points are the purple dots. Few manage to be stable, so to stay in the domain with high adaptation capacity, and most drift along the diagonal towards areas where adaptation capacity is in fact lower. Well, in fact, where growth is not as high as we would expect. And to have stable trajectories, that is possible only if you have very high labor productivity growth and very high availability of non-conventional fuels. So these are the conditions to manage to have that strategy reach its goal to have high adaptation capacity. And in other cases, if you have too slow labor productivity growth or low availability of unconventional fuels, then the strategy drifts. So these are just some illustrations of what can be done with multiple runs of a model. A few takeaway messages. I really think that we're at a state, well, we all know that we're not modeling for numbers. We have to keep that in mind, I think, and also to try to communicate that better. Because always when we are trying to communicate our results, what is picked is one number. And really that's something that is important to try to be better at. Then, again, something that we all know, that uncertainties do matter. We're really in a case of deep uncertainty. And it does matter for the evaluation of the cost. Also, the metric that you use matters. We saw that the use of the carbon tax revenue is the elephant in the room. It matters a lot. It's not just a matter of technology. Consumption behaviors are a major determinant of the cost efficiency of climate policy. And it's not about choosing a scenario, it's about choosing action today. For that, we need decision-making frameworks and processes to choose robust strategies under deep uncertainty. And I hope...
Is another way to state robust would be no regret, or it's not exactly the same thing?
Robust would be a strategy that reaches its goal in the most cases possible.
Okay.
It doesn't mean that it's no regret. It might cost something to reach your goal, but it manages to reach the goal.
Okay.
Elephant in the room means that's the most important
Yes.
issue?
It's one big important issue that we're not discussing enough. And that was probably one of the stumbling block of the carbon tax debate in France, I think, back in, I don't remember, some years ago. And what I was just saying is that we do need some decision-making frameworks and processes to choose actions today. And I hope that some scenarios analysis, just as I showed you, can help inform those frameworks. Now, some big limits to keep in mind. It's only a model. It implies many assumptions that can and should be discussed, challenged, improved. I'm saying that I'm quite safe because I didn't show you the model. So, but I'm really willing to discuss that with you and to open the black box with you if you want. And it's, of course, a model that is built on incomplete, missing, or inaccurate data, knowledge, and theory. And for sure, it's a simplified representation of the world. Maybe it's a too simplified representation. We know that there are for sure some missing feedbacks, but there's a limit to complexity. So modeling is a trade-off under many constraints. Again, what the uncertainties that we explored are only a subset of uncertainties that we could think of. There's no black swan included in what we looked at. So even if we did many scenarios, we should beware of spurious comprehensiveness. This is also a danger. Then we're using very poor metrics. GDP is a very poor metric. And some areas for further work or maybe collaborations to try to work towards a multi-criteria decision beyond GDP and carbon tax, taking into account inequalities in employment, economic structure, welfare and happiness. A lot of further analysis is needed to identify robust strategies and trade-off. And for sure, some work also has to be made to develop those decision-making frameworks and processes, and to see what link between scenario and modeling exercise can be made with decision-making to be more useful. So that's it for now.